So in this video, what we're going to do is we're just going to make a few little tweaks to the game just to try and make it a little bit more fun and interesting. The first thing we're going to do is we're going to get our spawning script. Can remove level manager and player movement. I think it's level manager. Let's get your spawning script. And here we go, we've got these instantiates. 1.2, okay, so we've got 2 spawn points. Cool, so what we need to do is we need to add a little bit of random to them. So where we got spawn, transform, position. And what I'm going to do is I'm going to make a new variable for this, which is going to be a vector3. And that vector3, we'll just call it spawn where. And spawn where is going to be set to a new vector3 value, and that is going to be a little bit random. We want a little bit of randomness to it. So what's going to be the best way to type this out? Basically what we want is we want this position and we want this a couple of times. So I'm just going to copy and paste this. Because the vector3 is made from 3 values. So we've got our X, Y, and Z. So if we go through, we type in each position, so spawn transform x.y.z, and it'll be on our x-axis. So if we go to our game, this is our spawn point, right? So if we move the value, we can see at x-axis, this is just going to give us a little bit of distance between them. And we could do it on different values such as y, but we don't really want to ever touch z. So we'll just apply this to our x as well, and it should be good. So for our x, we want a random range. So we want to put this in brackets. And we want to plus, so we're going to get that plus random dot range. Random dot range. And that will be, let's just do -10 and 10. And then close the brackets. So we're going to get our X transform, and we're going to add a random value between plus or minus 10 to it. And let's give that a test, see if that works. Hopefully that should work. Oop, no, it says we've got an error on line 27. I think I might have forgot to put my semicolon. I did. Okay, and it says on line 27 we've got an invalid expression for a closed bracket. Okay, so we're opening this bracket here. Maybe we don't need these extra brackets. Let's just get rid of these extra brackets. Give it a second to refresh. And it's still not happy. It still says we've got an invalid bracket. Oh, first of all, why have we got a comma here? Oh no, we do want that bracket. That bracket needs to relate to that bracket. Okay, I think that's good. Let's just test it and I'll show you the line. So, in theory, when they spawn, there should be a bit of difference between them. Nope, there won't be because we've not actually changed this position. So let me zoom out a bit so you can actually see this line. So we've got a new vector and it's on the X value here where we've got the random range. But what we need to do is where we're spawning, we need to basically change this from spawn position to spawn where. Right, and I know this is kind of complicated. But so when we instantiate our first one, we're going to be using spawn where. And that is going to be this value, which is the same as our old value, apart from we've got this plus or minus 10 difference. And I think this is our first one, so we should see it on this one. So you can see how that one spawned in front and that one spawned behind. And ultimately what that's going to do is it's just going to give us a bit more sort of difference between the vehicles. Maybe 5 is probably a bit high. Can we see in game view? Can we see that if it spawns? That spawned on top of the other one. That's fine. Okay, cool. So that's how we can use random range, but we can actually use random range in lots of different ways, and maybe actually some more useful ways. For example, we could do it on our car speed, but our car doesn't have speed at the moment. So what we need to do is make a car speed script. So let's make a car speed script. Create C# script, and we'll call it car speed. If yours are cars, might not be cars. Don't forget, no spaces, otherwise you're gonna have a bad time. Okay, so now we've got car speed. This is the script that we will apply. And let's just say we need to add a rigid body first of all. Has our cars already got rigid bodies? Does the spawner? It does already have a rigid body. That's good. And essentially what we want to do is we want to get component rigid body, and we want to add force. And how much force are we adding at the moment on these? We're in minus 15 on the X. So let's just open some brackets and we'll say minus 15, comma, semicolon. Now in theory, this should work the exact same way as what we've already got applied as this constant force. So if I go to my prefabs, because this is what we're spawning on our prefab, we want to turn off constant force and we want to add the script, which was what do we call it? I think we call it car script or something. Car speed. So let's find out. Whoa, that was fast. Cool, but we know it's working now. So what we can do, I mean, first of all, 10 is way too fast. We can use the same principle as we just used with our random range. So let's do that. Instead of it being minus 10, let's say random dot range between I don't know, what should we say, 5 and 12. So now not only have we got cars spawning at different positions, but we're also going to get the car moving. Cars moving at slightly different speeds. So particularly in this first one. Okay, I think they're going backwards, because I needed to use minus numbers. So random range between minus 5 and minus 12. Oh my god, type better job. Right, so I'm not sure how obvious it is, but some should be going faster than others. Maybe we should go more dramatic so we can actually see the difference. Let's go -1 and -8. And instead, let's switch this to fixed update because it's a movement script. We should always do movement scripts on a fixed update. Ultimately, though, because we're... Okay, now they just don't seem to be moving. We'll get there. Instead, because we're doing this on update, it's applying this force every single time. So let's try and put it on our start. And we're going to need much higher numbers. So we're going to have an initial shot of between -100 and -200. So instead of it applying the force constantly, which is also why we're getting that weird sort of acceleration because the car's speeding up over time and we don't want that. What we might try is an initial sort of force. So you see how it came out there but it barely sort of moved. We're going to need some much bigger numbers. So this is more like what you'd use for like a bullet, you know, because it gives you that initial sort of burst instead of a constant force. Ultimately, I think they've got too much drag. Let's go back to our car. And on our rigid body, you know what, let's turn off gravity. I think because that's what's creating the friction and slowing it down. Right, so because they're not getting that friction now, they're not really slowing down, but you can already see sort of some of the speed difference between some of them. I think the spawn's too wide, I might, or at least potentially move that back. Okay, I think we're getting there. So I'm going to actually set this to about 800. Let's give us even more. Save that. I'm going to open my other script back up because I don't know why that's shut. Assets. Because I did -10 and 10 between my spawn points there. So let's go to scripts and level manager, which handles my spawning. Sure, reload, why not? Okay. And where are you? Instead of it being -10, I'm just going to do 5. Like I said, I'm just using that to sort of create a bit more distance so it's not a steady sort of stream between them. What else should we do? Let's also, on our car speed, because we're applying this to our car, let's get it to destroy itself. So I don't know if you noticed, but if we press play and go to scene view so you can see, those cars kind of just exist forever. And you can see in the hierarchy, we just got a copy of these cars, which ultimately is not what we want. Over time, that's just going to make your game run badly. So let's open back up. Why are you doing that? Let's try and see what happens when we ignore. So at start, we can use, we could use something called destroy. And as you can see, this is going to destroy object. And we have a float. So let's type in destroy. And then we want to type in the game object that we want to destroy, which in this case is just ourselves. And if we put a float in there, this float t is the optional amount of time before the destruction. So let's just say 5. and stick a semicolon on that. Now what should happen is these cars should start destroying themselves. 5 might actually be a bit high, we'll sort of see in a minute. So we want them to destroy themselves around here. We could probably go down to 4, but 5's fine. Cool, that's pretty good. In theory, if I move this now, because it's using force, and rotate it 90 degrees, 180 degrees even, because it's applying relative force, will this spawn and go that way? No, it's still going the same way. Let's have a quick think about that. Could we change that? So we spawn in here, but we're taking the rotation. The spawn rotation. So I don't understand why it doesn't go in the way it should go. Okay, I think that'd take more messing with than it needs to. I think if we started trying to get the car's forward vector, which, is that easy to get? Get forward vector. Let's have a quick look on Unity API. So if there's ever something that you're not really sure on how to do, or you can't remember like a bit of code, the thing what you want to do is type in Unity API, and then go to this top link, and in here you could pretty much type in anything you want. So we just did a destroy, right? So we could go into here and find out, like say you remember that destroy is a thing, but you don't actually remember how to use it. So you could go in here, search for destroy. Wait a minute, because apparently this is slow. And then click on object destroy, and it gives you examples of how you could use the line. But if we want forward vector, okay, forward vector doesn't exist. Let's try it with a space. What I'm trying to find out is the forward vector, and that way we want to get it now. We don't want to use it, we want to get forward vector. Transform the position, forward vector times time. No, we don't want that. Can we get forward? Returns normalized vector representing the blue. Maybe this would do it. Because if we could find out its forward vector, we could apply the force relative to its forward, and it would go in the direction that the object is facing rather than the world location. Right then. Right then, it's the position of the axis to transform world space. Unlike vector forward, transform forward moves the game object while considering its rotation. Interesting. Let's have a quick look at that. So, how are they using it? Transform forward times speed. Ooh, that's interesting. That's clever. Okay, let's try it that way. I think that should work. So what we need to do is, I mean, we can still add, this is our speed. So let's create a new variable, which we'll call speed. which is going to be a float. So we'll just do public float speed equals, I don't know, we'll just put 0 for now. But then at the start, we're going to say speed equals this, semicolon, and get rid of u for now. So speed equals that. Then what we want to do is, I think it said we want to apply force, and that force is going to be let's get components, so this will be the game object. What are they doing? So they're doing velocity. So the rigid body dot velocity is equal to transform forward times speed. So if we use this same line, dot velocity, first of all we need to uncomment it out. So dot velocity, and that is going to be equal to transform dot forward times our speed, semicolon. So that should look at our forward axis, times this by our speed variable, and hopefully, well, let's just make sure it works. Oh, what did that just do? It did something. Interesting. It's doing something, but it's moving at such incredible speeds that we can't actually see it. Let's just use add force, because that's what we used before. Let's see if that works. Add force. And instead, we'll say that is going to be equal to let's try this again. Ooh, okay. So if I rotate this now, excellent, excellent. So you can see that basically, however now I put my spawn point, it's going to send the car in that rotation. Which means if I put you on this side of the road, okay, they're going down. Let's just, instead of using transform that forward, what do we want? Transform that right? Let's try transform that right. Excellent, so that's working now, which means all we need to do is rotate 180 degrees. Yeah, rotate 180 degrees. Which I just held control to do that. And we got cars that go across both sides of the road. Yeah! Whoop. I'm happy about that. Also, we don't want mesh renderer. We don't want to be able to see the mesh. Where was spawn point 1? Spawn point 1, let's just move you a little bit more left. Alright, so now in our game, in our first one, we've got cars that move left and right. And they're doing so with a bit more of a random speed. Go, 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 go. I mean, I think I need to really increase the amount that my pig can move, because the delay's not very good on that. But ultimately, that's awesome. So just on our pig and our player movement, what did we do? We did an invoke every 0.6. I'm going to change it to 0.4. And I need to do the same thing on the camera because we've got the same system on the camera. Oops. And set you to 0.4 as well, so we're consistent. And that should be, we can click it a little bit more. I still have to tweak the numbers a bit, but for now, can't even make it past the first one. Maybe its speed's too fast. I have to slow it down a bit, or increase the view of the camera. But for now, we've got some more random variables and values, and I know that was quite complicated. So awesome! If you managed to stick through that and you understood it, then you've done a really good job, because that is some advanced scripting right there. So good work, guys, if you made it this far.